Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel. Today's topic of discussion is one MCQ. The question is in front of you that which of the carbonyl compound has maximum dipole content in presence of water? So here four options are provided. So by the way student, if I say technically this question is incomplete. Instead of diol, I should have been told you that is JEE-mains diol, but I did not say it. And here do not get confused with some other thing, because simple question, so do not think too much. Now question, how can we solve this? So here look at this compound. Four compounds I have written. By the way, if you think diol, then remember one thing, it is JEE-mains diol, obviously it is actually the addition reaction with water. So it's an equilibration process here. So water, you may consider it's a carbonyl addition reaction, and water act as a nucleophile here. You can ask, sir, where is the acid, where is the base, catalyst. I'm not going that, a simple explanation. So this is, so one side is OH, another side is another OH. So that's why this is called diol. Since these two OH attached to same carbon, this is called geminal diol. Okay, and generally this equilibrium prefers to remain in the reactant side. This diol is not that much stable like the keto. Keto is more stable compared to this diol, because the C double bond O is more stable bond compared to two carbon oxygen bonds. Fine. Now I'm not going that much details here. Now here, if you look at, if you compare the diol percentage, for example this phenyl case, as this acetaldehyde case, benzaldehyde case, here obviously ketone, they are not that much. And now if you compare aldehyde versus ketone, obviously aldehyde have relatively higher diol content, JEE-mains diol content compared to ketone, but the amount or difference is not that much significant, student. Now what is the third option? It is aldehyde. So definitely it will have something, but along with that it have some extra stability. So I can say if you add water, water will be obviously added. So I'm writing in this way. This is OH, OH. By the way, remember this oxygen hybridization is sp3, so it's a band structure. And obviously there are two lone pairs. I'm not going that. Now here hydrogen. Next carbon attached to 3 chlorine electronegative atom. Now these 3 chlorine there. So each chlorine has 3 lone pairs. So that's why they can participate in hydrogen bond. Now we will be confused, sir, chlorine hydrogen bond, because hydrogen bond formation with chlorine is not common. We have studied one atom, fluorine, oxygen, nitrogen can form hydrogen bond because the electronegativity difference, etc. But by the way, if you look at the electronegativity value of chlorine, it is closer to nitrogen, nearly 3 point something, closely 3. So it's a significantly high electronegative. By the way, it is not general or common for chlorine to form hydrogen bond. This is one special case. Okay, so in this case hydrogen bond formation happens. And by the way, this compound name, remember, it is called chloral or trichloroacetaldehyde, and these molecules, this name is chloral hydrate, because water is actually got added here, and this chloral hydrate crystallizes. So here it is not an equilibration, it is a straightforward water addition. So two reasons for chloral hydrate formation. Point number one, this CCl3 has a very strong minus I effect, withdrawing nature. So it increases the electron deficiency at these carbonyl carbons. So it is a very good electrophile. Obviously aldehyde, so nucleophilic attack is easier. Although water is not a good nucleophile, but since this carbon is very much electron deficient, so that's why water can act as a good nucleophile and attack here for JEE-mains diol formation. And second thing, obviously stabilization of the diol, JEE-mains diol, by hydrogen bond formation. So that's why this compound C has 100% diol content. So in this case, answer is option B. So I guess this idea is clear for you. Thanks for watching. See you in my next video. Bye bye.